to module 15.9, dividing complex numbers. I believe I left one problem out in the previous video, so let's come back and do this one first before we continue to before we divide. So this particular example, okay, square root of 6 plus 5i times square root of 6 minus 2i. So again, for your methods, square root of 6 times square root of 6 is square root of 6 squared, or you can say square root of 36. Either way, it's going to be positive 6. Square root of 6 times negative 2i. Square root of 6 times negative 2i, negative 2 square root of 6i. All right, inner. Positive 5i times square root of 6, positive 5 square root of 6i. Ooh, this is interesting. Positive 5i times negative 2i. Positive 5 times negative 2 is normally negative 10. But again, I times I is negative 1 again. That will make my 10 positive. So here we do have some like terms now. The 6 plus 10 is going to give me 16. Are these two terms like terms? Well, both terms got I in it. Both terms has square root of 6 in it. In front of the square root of 6, negative 2 and positive 5 are like terms, so these two can be combined. So negative 2 square root of 6i plus 5 more square root of 6i will give me positive 3 square root of 6i. Okay, so that will be my answer right here. All right. So before we divide, let's go revisit this difference of square problem. All right, we conjugate it. So again, when it comes to division with two terms in the denominator, we got to conjugate. So we're going to use the same technique as before. Okay, is to conjugate a denominator, make them into a difference of square problem. So I'm going to multiply the conjugate of square root of 6 minus 7i, which is square root of 6 plus 7i, on the numerator and the denominator. So let me work this on the side, okay? Denominator, two terms for one denominator, put them in the parenthesis, minus 7i times square root of 6 plus 7i. So difference of squared is basically my conjugation. So my a squared, which is square root of 6 whole thing squared, minus my 7i whole thing squared. So let's use some power rule here. Square and square root cancels out. It's 6. Power rule will tell me minus 7 squared is 49. I squared is negative 1, which will make my negative 49 become positive. So my denominator now actually becomes 55. So if I can move this down here in a minute. So let's do the top. This is two terms representing one numerator, so I'm going to put them in the parenthesis. So that's square root of 7 minus I times square root of 6 times my square root of 6 plus 7i. So let's do a FOIL method here. Square root of 7 times square root of 6 times 7i. It's going to be square root of 7. 7 and 6 cannot be broken down where I got two of the same number. So I'm just going to multiply them inside with inside. 7 times 6 is 42. Square root of 7 times positive 7i is positive 7 square root of 7i. Negative I times square root of 6 times square root of 6 is going to just, well, square root of 6 times square root of 6 is square root of 6 squared, which is just going to be 6. So that would just be negative 6i. All right. Negative I square root of 6 times positive 7i. Negative times positive is normally negative. 7 square root of 6. But the I times I again will make this negative 7 square root of 6 become positive. So, look like no like terms. All right, so since I got no like terms here, what I'm going to do is put this term and this term at the beginning. So that would be square root of 42 plus 7 times square root of 6. And the two term with an I, put in the following. So I'm going to do the minus 6i first, and then plus 7 times square root of 7i. So basically, my whole entire numerator now has 4 terms. There's no like term to combine. So what I can do is kind of split them into 2 parts. The first 2 terms, the real part, separate from the imaginary part. So we can rewrite this as square root of 42 plus 7 times square root of 6, both term, over 55, plus, okay, the 2 negative part has a common factor of I, so we can kind of factor it out. So to say that's a negative 6 plus 7 square root of 7 over 55, and put the I right beside the fraction. We can do it that way. Because when we write it this way, we are saying this is A. Let me write this. This is like A plus BI form. Okay, that's why we write it that way. All right, let's try this one. So conjugate, so because I got 2 terms in the denominator, I will conjugate. So in this case, conjugate negative 6 minus 5i will be careful now. A lot of students get this thing confused. I got to make it into A plus, I got to make them into A minus B. This is like your A minus the B. So now I need an A plus B. So the A is going to be negative 6 plus my B is 5i. That's how I conjugate. All right, let's try it up here. Denominator, negative 6 minus 5i times same A plus 5i. So my A whole thing squared minus my B whole thing squared. Okay, negative 6 whole thing squared is 36 minus, all right, a little bit of power rule right here. 5 squared is 25. I squared is negative 1. Make my negative sign in front of it become positive. So this is basically 61 in the denominator. All right. All right, let's multiply the top together. Negative 5 minus 6i times negative 6 plus 5i. So negative 5, let's do a FOIL method. Negative 5 times negative 6 is positive 30. Negative 5 times positive 5i is negative 25i. Inner is positive 36i. All right, let's see, the last one. Negative 6i times positive 5i. Negative 6 times positive 5 is normally negative 30, right? But I times I will make my negative 30 into positive. So combined like terms, that's going to be 60. Negative 25i plus 36i is positive 11i, I believe. That'll be 60 plus 11i. So again, I can split this into, I can split the 2 term up top into 2 separate terms by saying 60 over 61 plus 11 over 61i. So that's your A plus BI form. All right. So a quick note before we finish up this lecture video. So this video, I just show you how to divide our complex number where when the denominator is 2 terms, we got to conjugate. That's why in the previous video, I show you how to do the difference of square again. So to help us understand to help us calculate the conjugation here, okay, involving with dividing complex number. Now, a lot of these problems can be done in the graphing calculator. And one of the main reasons why I did not show you how to do this in the calculator, because if we run into problems, okay, that involving with radicals, the calculator might not always give me the answer that I'm looking for or what the homework is looking for. Because calculator tend to take these radical that is not perfect square, give you a bunch of decimal answers. So that's the reason why I didn't really mention too much about do these in the calculators. So if your calculator is capable of doing these problems and give you radical answer, that will be fine. You can try to use them. If not, try to do these by hand. The way how we do these problems by hand is basically just like what we learned in module 11. Okay, where we do FOIL methods, multiply it out, combine like term. All right. So that will conclude this lecture video and last video for module 15 as well. Okay. Thank you so much for watching.